All right, I've been asked to go over the lesson on quantum numbers, and I'm just going to do a couple of quick sessions, a couple of quick questions, just to show you what it is that I've been talking about in the assignments, okay? So we know that we have four quantum numbers. We have the principal quantum number, we have the secondary quantum number, and we have the magnetic quantum number, and we have the spin. We know that the primary quantum number is just the period or the energy level, so it can be anywhere from 1 all the way up to 7. L represents the orbital type, so it could be 0, which is S, it could be 1, which is P, it could be 2, which is the D, and it could be 3, which represents F. All right? The ML obviously corresponds to the L value. So if it's the S orbital, we know that the ML value can be either, well, it can only be 0 because the L value is 0 and it only holds 2 electrons. Therefore, we only need one ML value. For the P, we know that we can have 3, and it's -1, 0, or +1. So it corresponds to the value with the range from minus to positive for that value. Obviously then for the D, we could have -2, -1, 0, +1, or +2. And then finally for the F, it could be -3, -2, -1, 0, +1, +2, or +3. Now within each of these, we can place 2 electrons. So therefore there's 2 addresses for each one of these positions. And those addresses correspond to either a positive spin or a negative spin. Okay? So that's kind of the foundation. So let's take a look what this looks like then as we take a look at the periodic table. So if you remember from the periodic table, we have the S block, we have the D block, we have the P block, and then obviously we have the F block. Okay? And within each of these blocks, there are 2 sublevels, or 10, or 6, or 14. Now obviously that corresponds to the S, the D, the P, or the F. Okay? So let's pick an element from the periodic table here at random. Let's just choose ruthenium. So number 44 here. So Ru. Now if I look at the periodic table here, I can see that. Now you might be tempted to say that this is 1, 2, 3, 4, 5. This is the 5th period. But remember the D block is one section lower. In other words, this first row in the D block represents the 3D, which means ruthenium is in the 4D. Okay, so ruthenium would be 4D, and if we go over 1, 2, 3, 4, 5, 6, ruthenium is the 6th element in, so its configuration ends in 4D6. Now, what does that correspond to in terms of the quantum numbers? Well, obviously, n equals 4. For the D, L equals 2. Now, it's the 6th electron, or the 6th element in that period, or in that block, and in that row. For example, if we just kind of draw out the row here for a second, and I know that there are 10 possible spots in that row. And again, if we look at that row, it could be from scandium all the way up to zinc. Or sorry, yttrium all the way up to indium. So we can see that 1, 2, 3, 4, 5, 6, ruthenium falls right there. Okay? Now, what else this block corresponds to, because this is the D orbital, or L equals 2, that means ML could have values of -2, -1, 0, +1, +2. That's 5, but There's 10 here, but remember, it gets repeated because this section corresponds to electrons with a positive spin. This section corresponds to electrons with a negative spin. So we can finish this up easily by looking at, well, here's ruthenium, so it's -2 and it's -0.5. So the complete set of quantum numbers then, or the 4 quantum numbers for ruthenium then, would be -2, and the spin
From you, Mr. Van Dam.
is -0.5. That's it.